This video is going to look at identifying different information from a graph. So the graph of a function f is given over here to the right, and from this graph of the function f we're supposed to identify the domain, range, x and y intercepts, and then identify these different values if they exist. Okay, so just as a reminder, the domain is the set of all x values, the set of all inputs you can put into the function and get out a y value. Okay, so the domain here, I'm looking at the x values, and x values run left to right on a graph, and you can see it here in very small numbers all the different x values. Okay, so it looks like if I start this function starts at when x is -4. Okay, so I can do bracket -4, and I include -4 because I have a closed dot, and the way we communicate that in interval notation, which is what we're going to be using to communicate the domain, is with a bracket. Okay, and so I'm starting at -4, continuing. At -2, I hit a hole. Okay, so I have to stop. My domain will break. And so I would go to -2. And since I have to stop there and I have a hole, I have to exclude -2. And the way we exclude a value is with a parentheses. Okay, but then the function continues on. So I need to union this. Then I'm starting at -2. Okay, and then I go, okay, -1, I still have a y value. 0, I have a y value. 1, my y value, it has a hole, so I have to stop again, and then have a right endpoint at 1 with an exclusion symbol of a parentheses, and then union this because I still continue, so I start at 1 and go until 4. And at 4 I exclude it, so I have to use a parentheses there again. Okay, next part, so again the domain, all x values, and we have to stop every time we hit a hole. Now range, instead of looking left to right, remember range is the set of all y values, all outputs. So I have to start at the very bottom, and this function starts at what looks to be negative infinity, or not negative infinity, rather, just -4. So I start at -4, and since I have a hole, I have to have a bracket. Okay, and now I'm starting at the very bottom and looking vertically. So I go up 3, -2, -2. I have a dot, but it's closed in, so I can keep going. And at -1, oh, okay, at -1 I have a hole, right? No, you don't, actually. So again, what you need to look at is, even though you have a hole, is there another y value at this value of y? So if I go over here, I do have a dot, a closed-in dot, even though it's not there, because it's a straight line and the function value is kind of filled in for us. So I can continue even though I have a hole. Okay, at 0 I actually have the same thing. Okay, and then the highest point is just going to be 1, so I can go forward to 1 with a bracket, and I'm done. Okay, be careful of this misconception. So even though you have a dot, check to see if you have another y value at that point. Okay, so that's the range. And now x and y intercepts, these are the places where it hits the axis. Okay, so the x-intercept is the place where where the function hits the x-axis. The y-intercept is the place where it hits the x-axis. And by default, we want to list these as ordered pairs, so an x comma y value, rather than just a single value. Sometimes we may ask you to do that, but for right now, default by listing it as an ordered pair. So the x-intercept here, okay, it looks like there's actually two places, here and here. Okay, but remember I have a hole here, so I don't actually have that point. So the only x-intercept is going to be at the origin, or at 0, 0. Okay, because again I'm looking where does it hit the x-axis, okay, and two places, this is the only place. Y-intercept, okay, I'm looking where it hits the y-axis, this vertical axis, and that's also at the origin. Okay. Then now f of minus 2, okay, well this is saying, remember we typically represent a function by f of x. Okay, so in this case, is it saying that the x value or the y value is minus 2? The x value, right? Because it's inside the parentheses. So negative 2 is the x value. Okay, negative 2 is this whole, negative 1, negative 2. Oh, but I don't have a value there. So actually what we have to say is this is undefined. Or you can also say DNE for does not exist. Okay. Then now this one instead, now this is saying f of x is equal to negative 2. So this is saying a y value, because f of x means y, so we're saying y is negative 2. And what we want to determine is the value of x that satisfies this equation. So I need to look at negative 2. So here's negative 2. I'm going to make a line, okay, and I'm going to list all values of x that satisfy this, or that intersect this line. So if I look on my graph here, it looks like there's two places when x is negative 4, or right over here when x is 2. Okay, and that would completely answer that question. Okay, so this is a video that kind of ran through identifying different pieces of information from a graph. The domain is, again, the set of all x values, and the range is the set of all y values. And when you make these, remember that every time you have a hole, you have to stop and think, okay, so is there another value at this point or not? If there is, great, then you can include it. In the case of the range, we were able to do that. Domain, we weren't able to, so we actually had to break it up and do unions. Okay, x and y intercepts were the places where it hit the x and y axis, and then these different function values, we had to either determine were we looking at an x value or were we looking at a y value, and then determine those values. Okay, and that completes an example on looking at information from a graph.